These are the notes for section 4.3, proving congruence ASA, AAS, and HL. Our objectives are to use the ASA postulate, the AAS theorem, and the HL theorem to test for triangle congruence. First, we'll start off with ASA. So last time we talked about SSS and SAS. A stood for angle and S stood for side. The definition here is if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the triangles are congruent. So remember that word included meant between. So if I had angle B congruent with angle X and angle C congruent with angle Z, I would have two angles. I need the included side. That means between the two angles, and that would be segment BC and segment XZ. So we're given a couple of examples right here. Our directions say find the missing congruent parts so that the triangles can be proved congruent by the ASA postulate. Then write the triangle congruence. So we see in letter A we have two angles, so we need the included side. So that would be AC and DF. So we would say segment AC is congruent to segment DF. That's what we would need to put in. And then we'd write our triangle congruence. So we would say triangle CAB. Remember, it's always good to name it in terms of the angle marks. So we have 1 and then 2, and then no angle mark is congruent to triangle 1 angle mark F, 2D, and our remaining angle would be E. So it'd be triangle FDE. Letter B is pretty similar. Again, we're using the ASA postulate. So we have one angle. We're told that they're right angles, angle R and angle Y, and one side. So in order to make that side included, we need to say angle S is congruent to angle X. So angle S is congruent to angle X. So if that's true, we would say triangle RST is congruent to triangle. So we have to start off with the right angle Y, the one with one angle mark X, and the one with no angle mark listed W. Let's keep moving on. We're going to do the even ones together. If you would like to try the odd ones. So for number 2, well, let's read the directions first. It says what corresponding parts must be congruent. So what corresponding parts must be congruent in order to prove that the triangles are congruent by the ASA postulate. And then we're told to write the triangle congruence statement. So for number 2, we know that by the reflexive property, WY has to be congruent with WY. So we're told by ASA, so we need to make that the included side, so we need to put the angle that touches it that's missing. So we already have angle W, or I should say XWY and ZWY. We need the other side. So our congruence statement would be triangle WYX is congruent to triangle WYZ. So our angle was angle XYW had to be congruent to angle ZYW. For number 4, we're given an angle. Again, we're given the, or we know the reflexive property, that side has to be congruent. So we need another angle. So that would be the angle there. That would be angle CBD is congruent to angle ADB. And our triangle congruence would be triangle CBD is congruent to triangle ADB. So if you're very careful about the letters with the angles, you can just change that angle into triangle and you have your triangle congruence like we talked about in the last lesson. So for number 6, again, we're given an angle and a side, so we need the other angle. That would make our side included. So we would say angle ACB has to be congruent to angle CED. And again, we can just write the triangle with the same ordering of the letters. We see when we do that, ACB is one angle mark, two angle marks, no angle marks. CED is the same thing. One angle mark, two angle marks, no angle mark. Let's go to the back side now. The other objective said that we would talk about angle, angle, side. This time, this is if two angles and the non-included side of one triangle are congruent to the corresponding two angles and the non-included side of a second triangle. Then the triangles are congruent. So again, we have two angles. So with our last example, we had B congruent to X and C congruent to Z. So let's do that same thing. This time we want the non-included side. So there's a couple different possibilities. One possibility is to say AC is congruent to YZ. That would be enough information to show that the triangles are congruent. So number 7 says, is it possible to prove that the triangles are congruent? So is it possible to prove that the triangles are congruent? If so, state the postulate or theorem you would use, explain your reasoning. So for number 7, we know by the reflexive property, WL is congruent to WL. So we have two sides and an angle. The angle is not included. So remember, whenever we have two sides and an angle, the angle must be included. This is SSA. So this is not enough information. Our reason would be we do not have the included angle. So let's take a look at number 8. We can fill in a little bit more information. We have vertical angles, so I know that angle TSN has to be congruent to angle USH because those are vertical angles. And we have angle, angle, side. The side is not included. It is not between the two angles that are marked off. So you would say triangle TSN is congruent to triangle USH by angle, angle, side. Our last example, number 9. We know that both of these have to be right angles because they form a linear pair. 90 plus 90 is 180. And we have a second angle. We have the non-included side again. So we would say triangle NHK is congruent to triangle NTG by angle, angle, side. So for numbers 10 and 11, we're told to write a 2-column or paragraph proof. We're going to write 2-column proofs primarily in this class. So try 10 on your own. We're going to do number 11. So for number 11, our 2 columns are our statements and our reasons. So before we do that, let's figure out what our game plan is going to be. Well, we know we have these two sides that are marked off. That's given information. We know that we have a common side. Remember, that's the reflexive property. And lastly, we're told we have parallel lines. That's given to us. So whenever I connect the lines there, I should see that by alternate interior angles, that I'll have two congruent triangles. That'll be side angle side. So the last step in my proof should be triangle ABC is congruent to triangle DCB, and that would be by side angle side. So now we just need to express that in terms of a proof. We need to actually prove it. So we'll start off with our first side. We're going to say segment AB is congruent to segment CD, and that's given information. There it is up there. It's given information. The other side that we have that's in common is segment CB is congruent to segment BC by the reflexive property. So then we use our given information again. We say segment AB is parallel. Remember, that symbol means parallel to segment CD. That's given. And again, let me just trace those lines and show you. Whenever we have CB as our transversal, we have angle DCB congruent to angle ABC. And that's because alternate interior angles are congruent on parallel lines. So now I have my side angle side. So the last part of this proof is just to copy down what we were supposed to prove. So triangle ABC is congruent to triangle DCB. And our reason is just SAS by the side angle side postulate. Let's hit our last objective, which is to talk about the hypotenuse leg theorem. This says if two angles and if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the corresponding leg of another right triangle, then the two triangles are congruent. So with this, we see right away that we have two right angles. So all I need is for legs to be congruent and the hypotenuse to be congruent, and that would be enough to show that these triangles are congruent by hypotenuse leg. This should be easy to show because by the Pythagorean theorem, we would know the third side would be congruent, and that would just be side, 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 right? So let's take a look at number 12. We have a right triangle. And by the reflexive property, we know that xz is going to be congruent to xz. So we have triangle YXZ, so that's using 1 tick mark to 2 tick marks, is congruent to triangle 1 tick mark to 2 tick marks WXZ. So that's by hypotenuse leg. So I like this next example, number 12, because it shows you, or sorry, number 13, because it shows you just because we have a right triangle does not mean that it will always be by hypotenuse leg. So because we're told BD is perpendicular, remember that upside down T means perpendicular to AC, so we have two right triangles. Just because they're right triangles doesn't always mean they're congruent by hypotenuse leg. We know that BD is congruent to BD. And lastly, it says BD bisects angle ABC. So that means this smaller angle is going to be congruent to this angle. So our congruence statement in the end is going to be triangle BDA is congruent to triangle BDC. And our reason is going to be by angle, side, angle. We're not given the hypotenuses are congruent, so it's not going to be by hypotenuse leg. So make sure you do those few problems that I didn't do. That was numbers 1, 3, 5, and 10. And if you have any questions, please come to class prepared with them.